Hello, and a big warm welcome to Straight4ward Science. Today we are going to look at forces, so that means physics. This video is beneficial for any GCSE exam board and Key Stage 3. First, a brief history on forces. You will have probably heard of the classic tale where Isaac Newton discovered gravity from an apple falling on his head. Because Isaac Newton's findings were so groundbreaking, forces are now measured in newtons. The symbol for newtons is a capital N. In physics, it makes a big difference if a symbol is a capital or not, as a capital N may mean something different to a lowercase n. The larger the number of newtons, the greater the force. For example, 100 newtons would be a large force. And the opposite applies for small forces. So the smaller the number, the smaller the force. For example, 1 newton. All forces tend to go into two categories, either a push or a pull. And we are going to look at some forces in a little bit more depth. Forces are also either contact, which means the objects touch each other, for example a tyre touching a road. A force called friction would act here, but we will discuss friction soon. Forces, however, can also be non-contact, which means the objects don't touch. For example, a magnetic force. If you were to place two south poles of a magnet together, they would repel, meaning push away from each other, so you couldn't get them to touch even if you wanted to, thus making it a non-contact force. Lastly, forces can be balanced, which means that they're acting in equal strength to one another, and would mean that the object that they were acting on would either be stationary and it wouldn't move, or it would cause the object to move at a constant speed, for example 50 miles an hour. However, if the forces are unbalanced, for example one force is acting more strongly than the other, this causes the object to move, either by changing its speed or direction. Moving on, let's talk about friction. Friction is a force we encounter almost every day. For example, if you rub your hands together, this creates friction. So how do we describe friction from what we're doing with our hands there now? We would describe it as when two or more objects rub together. It's as simple as that. Friction comes in different forms. The first form we are going to discuss is air resistance. You might have felt air resistance before when you've cycled. The second type of friction is water resistance, which you might have felt when you've went swimming. In order to reduce our resistance in both of these instances, we would try and make the object, which in this case would be ourselves, more streamlined. To make an object more streamlined, for example us, we would either wear some tight clothing if we wanted to go on a bike ride, or wear a swimming cap if we wanted to go for a swim. We have now covered friction. Another force is drag. Now drag is just another way of saying air resistance, which we have also already covered. Another force is spring force. This is the force of a stretched spring, which is also known as Hooke's law, but we will be covering that in another video. Another force is applied force. For example, this would be the force applied when someone wanted to push a desk from one end of the room to another. Another force is magnetic force. This is the attraction or repulsion between two charged particles. For example, if I had a north pole of my magnet and I put it next to a south pole of my magnet, they would become attracted to each other. However, if I had two north poles, they would repel each other. The next force is electric force. Now this is very similar to magnetic, as it is also between two charged particles. However, you would find electric force in an electric motor between the magnet and the coil. And the last force we are going to cover in today's video is gravitational. Now, you might not have heard of the word gravitational before, but you've probably heard of the word gravity, which is the force that Newton discovered. This is just when a mass of any object is brought to another object. So gravity is acting on us right now. The forces in red are non-contact forces, that means they don't touch to act. And the forces in black are contact forces. Let's talk about how a force can cause an object to move by either speed or direction. This is called a moment. This causes an object to turn. We can use a seesaw as an example to show moment. A seesaw has a pivot in the centre. Now, before we talk about moment, we need to know its formula. We would calculate moment by multiplying our force in newtons by the distance of an object away from the pivot in metres. In my example here, the object on the left-hand side has a force acting downwards of 10 newtons. And the distance it is away from the pivot is 5 metres. So, we would do 10 multiplied by 5, which would give us 50. Our moment for this would be 50. Now, let's compare this moment to the moment of my object on the right. My object on the right has a much greater force acting downwards on it, of 25 newtons, but is not as far away from the pivot as what my object on the left was. This is only 2 metres away from the pivot. So in this case, I would times 25 by 2, also giving me 50. Now, notice my unit for moment. It is in newtons per metres, so a capital N and a lowercase m. But what do we notice about the two values for our moments? That's right, they both equal 50. If they both equal 50 newtons per metre, are the forces balanced or unbalanced? The forces are balanced, therefore meaning my seesaw does not turn, it does not move. This would be different, of course, if I had 2 participants wanting to sit on the seesaw and one participant weighed only 10 newtons and the other participant weighed 100 newtons, but they both sat the same distance from the pivot, meaning they would have different moments, and therefore my forces would be unbalanced. So my seesaw would go down to the side of the person who had more newtons, who had the most force. Thank you ever so much for watching. Please don't forget to like and subscribe, and see you next time.